Right. Question number 197. Read the question. A combination of two thin lenses in contact behaves as a converging lens of focal length 40 centimeter. If one of the lenses is converging lens of focal length 20, what is the power of the other lens? Now, combination of two lenses. When we have combination of the lenses like this, when we have two convex lenses of focal length f1 and f2, resultant lens should be a convex lens, right? And this focal length should be smaller than smallest focal length of these two, right? Resultant focal length should be smaller than the smallest focal length of f1 and f2, which means f should be smaller than f1 and f2. Then power p equal 1 over f. No? Power becomes maximum. Power of this one is, if it is p greater than, let this one p1, this one p2, p1 and p2, right? To the okay. This is first arrangement. Second arrangement, if you are given two concave lenses contacted with each other, focal length f1, f2, corresponding powers p1, p2, the resulted lens of the focal length f, it should be f smaller than f1 and f2, not f1 plus f2, f1 or f2, which one is the minimum one, the resultant one should be smaller than the minimum focal length out of the given two, right? Then third thing, as same as the power, no? Power P resulted one should be larger than P1 and P2, done. Okay. When we have the combination, can you write down until here or like this? When we have this kind of convex and concave two lenses of focal length f1 and f2, resultant one will be decided by short focal length. Let it, if f1 smaller than f2, resultant lens should be a convex one. If f2 smaller than f1, which means power p2 greater than p1, here power p1 smaller than p2, that's it, right? And then the highest power one, which means the short focal length one, is the resultant length. Then out of these two, f2 smallest one, then resultant one is concave one, right? Okay. Anyhow, resultant focal length is written 1 over f1 plus 1 over f2. This could be the standard equation. Done? Right. We including the sign convention too, right? If it is convex lens, focal length should be minus, concave focal length should be plus. Corresponding focal length should be adopted to the equation. Right. Can you manage the summary of this one? Summary of lens combination. The resultant one is decided by short focal length, which means largest power. Largest power consists with highest, smallest focal length, no? Right. Okay, clear. Then, okay, this one is the lens combination. No. Now we have the question. What do you say there? Combination of two lenses having the focal length of 40 centimeter. Then here, this one completed, right? Okay. Here two convex lenses resulted one convex. Curvature should be larger than these two. Here concave, concave, then resulted one concave. Curvature of this one greater than these two, right? It's a huge curvature available than these two. And here resulted one curvature lower than this convex. Curvature, this curved position, smaller than this one, right? As the combination take place, plus and minus combination. This is the common equation. Right to the finish. Can you manage 197? What do you say? We have to write common equation 1 over f. F is 40. Combination of two lenses contacted behaves as, can be underlined? Converging. Converging means resulted one becomes minus. By subjecting to focal length, 1 is 20. 21 is mentioned converging. No? Should be minus plus 1 over f. Can we simplify this one? One over f becomes 1 over 40, it's minus here plus 20. So 1 over f becomes 40 minus 1 plus 2. F becomes 40 centimeter. Final answer consists with positive sign. Then the resultant lens is concave or diverging. Diverging lens is the resultant one. Right. Can we manage the final answer? Okay, let's start 198, 199, and 200. Use 5 minutes to complete to recognize the final answer. Let's start. 3 questions you should complete. Is it like this? Right. This one is the focal plane, no? Here we have focal plane. Like this, focal plane. The line perpendicular to the principal axis going through the focus. That is the focal plane. Now consider line drawn across the optical center is a light ray. Assume the line going through the optical center is another ray, and here we have incoming light ray, and it is parallel with line across the principal axis. Then consider these two are the real light rays. Then they are parallel to each other. No? Parallel rays are diverge from the point of focus if the light rays are parallel to the principal axis, like this. If the lens is like this, here we have plane of the lens. This one is the principal axis. Right. If it is diverging lens right here, if it is diverging, right, like this, according to the question, diverging lens, the light ray parallel to the principal axis, like this, they are diverging, no? Right here, from a point of on the principal axis, like this. Right here. Parallel beam of light with the principal axis diverging from the point of focus. This could be the focus. Right, Buddha? Okay. But if the light rays are parallel to each other, but not to the principal axis, they are not converge or apparently diverge from the point on the principal axis. Say it again. If the light rays that are not parallel to the principal axis, but they are parallel to each other, will be diverge from a point on the optical line across the focus, like this focal plane. These two light rays should be diverge from a point on the focal plane. Yes, then this should be the path, no? Let's see. If this one is the light ray, they are diverging from a point on the focus, right here. This is the diverging path. This one, here, this light ray and this light ray should be met at a point. They are meeting at a point right here on the focal plane, which is drawn across the perpendicular line of the focus, right? Okay, then the light ray goes like the point of A, no? This one is the answer, right? Can you copy the diagram? For the extended lines behind from the light ray, it should be better to draw by using broken lines, right? Okay, let's start. Right, 199. Same process. But this one is convex lens, no? Let's see, process of convex lens. If we have convex lens like this, here you are given principal axis. If the light rays that are drawn to the principal axis parallel to each other, they are converging at a point on the principal axis, right? Then this is called the focus. But if the light rays that are not parallel to the principal axis, but they are parallel to each other, this one is the mentioned line, right? Broken line. Assume this one is also a light ray coming like this, right here. They are converging. They are converging across the line of the focus. This one is the focal plane now. This is the focal plane. Then light rays should be converged. This one is the light ray. Let it the dark line. This one is the corresponding path of this light ray. Here we have light ray and this one is the ongoing one. So it seems D is the correct one, right? Okay. You can manage the answer. Can you copy the diagram? Assume this one is also a light ray, right? Extending that one by using that line, we should identify the exact point of which the light ray entered across the line. No? Then light ray is going through point of D. Then D should be the answer. To identify that one, we have to draw the focal plane. No? Yes, this one is focal plane. Always parallel beam of light, they are meeting on a point on the focal plane. If the light rays are parallel to each other, right? Okay. Then complete this one and use the next one. Okay, then it's better to copy the line across the optical center. Line across the optical center. This one like this, which is parallel with the given line, right? Given light ray is this one. Then you have to copy another line. Let it a light ray which is going through the optical center, that must be parallel with the given line, right? Okay, then the basic theory, both the parallel line should be connected with each other at a point on the focal plane. This is the line of focal plane. This one is the line of the focal plane, right? Line of the focal plane. Then this is the path of the light ray. Light rays going like this. This could be the path. Here, this one and this one, they are definitely meeting on this point. But by copying the diagram, the plotted point is not exactly identified across the light ray, then it's better to consider A, right? Can you manage A like here? Not this one, right? Okay. Okay, let's see the next questions. Okay. Can we complete question number 201, 202, and 203, and 204, right? From 201 to 200, or most suitable point you can select, right? When the diagrams are drawn, Buddha, sometimes the points may be deviated here and there. That is drawing error, but not the answering error process. Then can we complete now? Quick as possible. We have to do 4 questions. Let's start. Right, next one, number 201. The focus of the concave lens is F. The figure on the right shows the incident of the light ray on it. A point most probable on the refracted ray. Same process, no? Right. We have to copy the line across the optical center like this. Right here. This one is the line across the optical center. Then the light ray should be diverge from the optical plane, no? Optical plane is this one. Here we have optical plane. Optical plane is this one. Then the arrangement of the light ray should be like this now. This should be the path of the light ray, no? Is that clear, Buddha? Here, light ray comes like this, diverge right here, diverging from here, no? Both the extended lines should be contacted right here. The line across the optical plane. Focal plane. Line across the focal plane, both the lines which is drawing through the optical center and the refracted light ray extended one should be contacted right here. Then this light ray almost contacted with the point A, then answer should be first one, right? Okay, complete the final answer. Answer is A. Right, 202. It's a convex lens. Drawing the line across the optical center right here. This one is the focal line. Then this should be the focal plane. And the light ray must travel across the optical plane like this now. Here we have ongoing light ray, and then this one is the path of the light ray, right? Can we change this point D right here? Can we shift? But most close in one is A, no? Then we can consider point of A, right? Take the answer A, closest one. But no matter. Copy in the points. We have some doubt, no? Okay, right. Next one. 203. Again, we have diverging lens. light ray going like this. This is the line across the optical center. And this one is the focal plane. So the light ray focal plane is this one, no? Here we have focal plane. Then the light ray should be diverge from this point, no? Light ray should be diverge from that point right here. Done. Then close one is B. Suitable answer is B. Light rays diverge like this. This one diverging from a point on the focal plane. Therefore, closest one is B, no? Yes. Manage the final answer. It's B. 204. 204 next. Quick as possible. Can we complete now? Right. 204. The point corresponding to the corresponding refracted ray can be. Same process, no? Okay. This one is the parallel line drawn with the given light ray across the optical center. Then here we have focal plane. Then light ray should be converge as a convex lens, right? Converge across the point like this. Converged. And then the light ray returning apparently diverge like this now. Okay, take the closest one. Around F, no? Right. Done. This kind of arrangement of light rays to be identified first. Okay, then two questions we have to do. 205 and 206. Can we complete quick as possible? Okay, let's start. Right. 205. The distance between an object and the real image formed by the convex lens cannot be. Let's see. Distance between object and the real image, like this, no? Here we have convex lens, principal axis, keeping an object in front of the lens to form real image. So the real image can be formed here 2f, f, 2f like this. Real image can be formed from focus to infinity. If the object is placed, u becomes infinity. Image will be formed on the focus. If u is infinity large, image should be the focus. Reversible, vice versa. If the object is focus, image distance becomes infinity large, right? Then we can keep the object from focus to infinity, this side, to form the image from focus to inverted, focus to infinity. Now, right. Cannot be greater than 2f, real image possible. Greater than 2f. If you keep the object in between f and 2f, image distance greater than 2f. Next. Less than 2f possible. Less than 2f, in between these two, we can manage the image if the object is kept beyond 2f, right? If the object lied right here, small image is formed like this. Greater than 4f also possible, no? Image distance greater than 4f possible. But they need the distance between object and the real image, no? Here to here. Image position from object to this one, no? Again, greater than 2f possible. It's okay. Next one, less than 2f. 2f, less than 2f. It is not possible, no? Less than 2f means if this one is the convex lens, here, focus, here, focus. If the object is kept at here, infinity long distance image available, gap in between 2f means this kind of one, no? This is impossible. Greater than 4f possible, less than 4f also possible, but less than 2f is not possible on f. On f, it should be a different answer. Can we release this one for that? It is not having the correct typesetting. Then remove that one. Then according to 4 answers, we have second answer. They need distance between object and the real image. Object and the real image. Okay. Less than 2f is not possible. Right. Okay, then done, right? Okay. Next question, 206. The layered lens shown below is made of 2 types of transparent material. This one is first material, refractive index N1, this one N2. Then separately, we have 2 lenses. This one lens, this one is the other lens. Then this is acting as the focal length of f1, this one focal length f2. 2 lenses, no? One is this one, the other one is this one. Then 2 images will be formed as we have 2 lenses. No worries, right? Okay. Upper lens is one of the lens. Lower lens is another lens, right? They are forming separate 2 images. Brightness of both the images will be low compared with the brightness of the object. Right, Buddha? Okay. 206. Correct answer is second one. 2 images are formed. Okay. Let's see the others. From 207 onward, one by one separately can be managed. Let's start. Can we manage this question? The maximum and minimum distances between convex lens and an object for the magnification of a real image to be greater than 1. Okay, it's a real image. Underline real image. Copy a diagram. Convex lens. Okay. This point, focus. This point 2F. Let this point focus. This point 2F. Right. The maximum and minimum distance between convex lens and an object for the magnification of real image to be greater than 1. Can we check? When you keep an object on here, infinity long distance, image distance covered in infinity long distance, then infinite magnification available by keeping the object on F. If you keep the object on 2F, then if you bring this one until 2F location, it will form same size image. No? Then from here to here, you can manage the objective distance in between F and 2F. In between F and 2F, you can manage, no? In between 2F and F, you can manage the objective distance to have infinity long distance image. If you keep the object right here, image becomes less than 1. Here, greater than 1, no? Greater image should be formed. Then correct answer is in between 2F and F. If this is O1, infinity long distance available. If this is O2, this one is magnified image is resulted, let it I2. If this is O3, this one is I3. This is diminished one, right? Okay. Can you manage the answer? Okay. Next one, 208. Read the question and copy the diagram. A convex lens forms a real image of 4 centimeter long on a screen. On a screen like this. Here we have object, right? This is the point of the object. If you keep the lens right here, image will be formed on the screen. No? Image will be formed on the screen right here. It is a magnified image. If this is H, let this one H1. Respect to the figure, you can say this one is objective distance. This one is image distance. So we can say this one is A, this one is B, distances, right? Without disturbing the object and the screen, again, real image is formed on the screen, which is 16 centimeter long. This one is 16 centimeter long one, right? H1, let it 16 centimeter, clear. and this without disturbing of the object, right? Here we will have another image by keeping the lens away, another location right here. This is L1 location here, L2 location. Then a small image will be resulted on the screen. Let it H2. H2 is 4 centimeter. Initial one 16, second one, okay, according to the given values, right? Okay, done. Then Pute, the length should be prepared like this, no? Here, this one is now to be B, and this one to be A, right? Can you copy the diagram? This one is A, this is B, this is A. The locations are interchanged. This is explained like this, Pute. Let's see. Here we have convex lens, right? If you keep the object in between F and 2F like this, image will be formed beyond 2F, right? Here F, here 2F, beyond 2F. When you keep the object in between, if you shift the lens until the objective distance is like this or reversible one, then here, if this is A, this must be B. If reversible one, if you keep the object right here, image will be formed like this. If the objective distance is again B, image length should be A, no? Reversible of that one. Yes, that is the position, right? Okay, then let's start the calculation. Okay, then this one is the location 1, location 2. Okay, calculation. Considering the linear magnification on L1 location. වැඩි අහුනොත් ඇදගෙන යනවා මිසක් බල ලියන්න එපා බලන් ඉන්න ලියන්න වෙලාව දෙන්න. Right, we have enough time, right? Okay, ML1 is first thing H1 over H. ML1 again we can say image distance B over A. Like this one first one, here second one. ML2 here same linear magnification at the L1 location is written by considering heights H1 over H. And it is also written by using distances, objective distance B, image distance A. It is repeated for the second location of the lens, ML2, then image height is H2, objective H, like this one, third one. ML2 again we can say by using image distance A and objective distance B right here. Clear with that? Right, this is fourth one. Then you can say second statement and fourth statement we can multiply with each other. How? ML1, ML2 comes as B over A multiplied by A over B, right? Then ML1 into ML2 equal B cancel, A cancel, it becomes 1. Let this one, fifth one. This is an MCQ question, right? Real statement here. Okay, and again first one and third one multiple with each other. First one and third one. First one, linear magnification multiple by linear magnification of L2 equate H1 over H into H2 over H. Then this one becomes 1 from fifth equation. Here H1 H2 over H squared. Then H becomes H1 H2 root, right? If you have enough brain capacity, you can by heart this one, no matter. We'll have the final answer. How? Here, according to the figure, H equals 16 into 4 root, no? Then H becomes 64 root 8 centimeter. Correct answer is first one. Right? Can we copy whole diagram and hold the calculation? After that, you can complete for the question number 200 and yes, 9. Let's start now. Same process, 209, also same process. We can extend this one, right? Quick as possible. Can you start now? Okay, next one. 208. A convex lens formed the real image when an object is moved along the axis of the lens image 3 times the size of the object are obtained when the object is at 16 centimeter and 8 centimeter from the lens. The focal length of the nature of the lens, focal length and the nature of the lens, right, can be considered. When an object is moved along the axis of the lens, like this, when an object is moved along the axis of the lens, three times size of an object are obtained when the object is at 16 centimeter. Right here, object, then put this 3 times available here, like this, 3 times magnified image. And if it is 8 centimeter, again 3 times, no, then it won't be the real one. It should be virtual one, like this, 3 times of one, right here, 3 times. If this is 8 centimeter, this should be 24 centimeter. If this is 16 centimeter, when the object is at 16 centimeter, this could be 48 centimeter. Then you should know for this one O1, this is I1, it is real. And for this one, object O2, image is this one, here, 24. Then put a focus should be lied in between these two. Anywhere, the focus should be lied in between 8 and 16 centimeter. And it should be a convex lens. Reason, it should be a convex lens. Reason, this kind of 3 times magnified image never formed by concave lens. Concave lens is not possible to form this kind of magnified image, no? Then this is convex lens. Here we can remove this answer. It is 4 centimeter. Then it is, if the focal length is 4 centimeter, this won't be lied inside the focus. No? This is wrong. As well, concave wrong. And this may be the correct answer. This is 8 centimeter. By placing the object at 8 centimeter location, infinite long distance available. Therefore, this is removed from the answer as well. This is also removed. 4 centimeters not possible. Then, by removing the other answers, we can select the correct answer as 12 centimeter without taking the calculations. That is understanding, right? Okay. Then, if you need to take the calculation, use the lens formula for the one of the given objective distances, 116 or 48. Use the lens formula. Or 24 and 8, use the lens formula. Done, right? Okay. Next question, 210. This one clear, right? Okay. Copy the needed one. And see question number 209. 210. The distance between an object and its real image formed by the lens is d. If the magnification is m, the focal length of the lens is, right, can we copy the diagram? Distance between the object and the real image. Let this one object, this one is the real image. This gap is d, no? Let this one is u, this one is v. First thing, v plus u equal d, and magnification is m. v over u is m. The focal length of the lens is, can we take 3 minutes to complete this one? Right. Let's start now. Okay, can we consider the process? Right, first of all, Daruni, we should identify this statement, like it first one, and this one, second one, right? Okay. Then we can introduce Lenz formula for this one. Let's see. Then hadane kanavatta. We'll have enough time. 1 over V, 1 over U equal 1 over F. Real image, no? Lenz formula is used. Then, when we use this equation, whole thing, multiple by U, right? By considering that and this whole equation, multiple by U, like this. U over V minus U over U and 1 over F. Then sign convention should be applied. No, this is plus. Towards the direction of light rays, minus sign, backward, plus sign. So V minus U plus F minus, right? Then U over V is inversion of this one. V over U, reciprocal is U over V. Then you can say here 1 over M, right? 1 over M. Here U cancel, minus 1. This becomes minus. And this one is also U, no? U over F also minus. Multiple by minus. This whole equation multiple by minus. Simplification activity. Minus 1, right? Then we have here 1 over M plus 1 equal U over F, right? Then we can say here M is common denominator. 1 plus M equal U over F. Let this one third one. Here we have an arrangement of 1 plus M over M equal U over F, right? Keep this one third one. And from this one, second one, we can say V is UM. V equals UM. Can we consider this V instead of this one? Then from first equation, we can say V plus U. V is UM plus U equal D. No? U common factor, take it out. 1 plus M equal D. Then U equate D over 1 plus M. D over 1 plus M. Then instead of U, we can apply 1 plus M over M equate from third one. U is that one, no? D over 1 plus M divided by its F here, no? So this one becomes 1 plus M, cross multiplication of this one, 1 plus M, and these two, we can say dm divided by F now. Then F becomes md divided by 1 plus m, that of squared. Done. Final answer, nearby fourth one, no? md over m plus 1 squared. Done. Fourth answer is the correct one. This is applied one, right? First of all, we should identify this one. First thing, this one. Okay. This one is the first thing. Second thing is this one. Management of the given data. And third thing, identifying this one. And this is having reciprocal, no? Reciprocal values should be simplified by considering one of the given factors, the suitable one is here. When you subject V, we have product UM now, then easy to simplify. When you subject U instead of V, U becomes V over M, right? 1 over V over M substituted with this one for the hard to simplify, but no matter. Even though when you subject U or V, any kind of thing, final answer should be like this. No worry, right? You can subject any term for the V or U from these two equations and some substitution with this one. Then we can take the simplification, no doubt, right? Instead of multiplication by U, you can use V for the multiplication of this equation, whole equation multiple by, yes, whole equation multiple by V instead of U, then V over V, then V over U, and V over F is simplified by using those two equations, right? It is also process. We can use that thing too, right? But this is easy. Okay, complete this one. And if you have completed this one, can I have 211 now? Question number 211. Let's start. First, complete this one clearly. right? Enough time to complete. 211, 2, right? Let's see the process. In the displacement method, the convex lens is placed in between an object and a screen like this. Here we have the convex lens. The real image formed by, if the magnification in two positions are M1, M1 is large one, no? Right? If the object is right here, image distance like this, and the distance between two positions of the lens is D, right? Then this is the first location. If the magnification in two positions are M1 and M2, and the distance between two positions of the lens is D, right? Can we manage like this? When you keep the object right here with the gap of A, image distance becomes B. Here we have largest magnification. Magnification is M1. What is the highest magnification? M1, no? If you shift the lens right here to have this one is B and this one is A, then here we have another image of the magnification M2. Okay, then first thing, M1 is B over A and M2 is A over B, right? First thing is that one. Then you can say B is M1A, first one, and from this one, A is M2B, right? This is second one. Then we can identify objective distance and image distance on the given position in terms of their corresponding magnification and the other length. Image distance with the objective distance and corresponding magnification here. Image distance at the second step or objective distance at the first step in terms of image distance and magnification, right? And gap in between these two locations is D. Done, right? So the D is B minus A, no? Here to here B, here to here A, here to here B, here to here A. D plus A is B, then D equals B minus A, no? Yes. D is B minus A. Then we can say From that one, let this one third one. From that one, we can say D equal B minus A. B minus A. A is M2B, right? Then D becomes B common factor. It's 1 minus M2. Then B becomes D over 1 minus M2. Let this one 1, 2, 3, 4. Fourth one. And from the same one, D equal, it's B minus A. B becomes this one, right? M1A. B is M1A minus A. Then D equal A M1 minus 1. Then A becomes D over M1 minus 1. Then using Lenz's formula, 1 over V minus 1 over U equal 1 over F. Application of Lenz's formula. Can I have 1 over V? V is B, no? For the first location. 1 over V is B. B is D over 1 minus M2. And apply the sign convention towards the direction of light rays, sign convention minus, backward sign convention plus, right? Minus 1 over U, objective distance. 1 over U is, objective distance is A. A in terms of, we have here D over M1 minus 1. Clear with that? Equal 1 over F sign convention minus. Then whole equation multiple by minus, 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 minus cancel, becomes plus, no? It's here. One over D over M1 minus 1, no? Yes, okay. Then simplification. This one goes up, D common factor, no? It's 1 minus M2 over D plus M1 minus 1 over D equal 1 over F. Here, common denominator D. D for D1, it's 1 minus M2 plus here M1 minus 1 equal 1 over F. Then plus 1 minus 1 cancel. Then F becomes D over M1 plus M2, right? Okay. Put the final answer. D over M1 plus M2, right? Here multiple by minus, minus, minus cancel, then becomes plus, right? Therefore, M2 plus M1 resulted. Answer is first one. Okay. Put the correct answer. Right, Buddha. Let's start the next session. Measuring instrument part. Next instrument is traveling microscope. Should be discussed, no? Right. Take the next page. About traveling microscope. Okay, question number 212. And with the question, we have to discuss about traveling microscope. Let's see. Okay. Can we name the components for that? Identifying the components. Okay. Diagram clear, no? Right. Can we name the components for that? Right. First one, A. Name A. A is vertical fine adjustment screw. Right. By turning this one, microscope component, this whole part will be moved upward and downward very smoothly. While small amount of distance traveled by the microscope upward direction by turning this one. To operate this one, before operating this one, the Titan screw that is called rough vertical adjustment screw, which is light behind the traveling microscope. It is not seen on here. It is light behind position, and that screw should be well tightened, right? You have to tight it well, not release. Tight it well before operating A, right? Then behind one is vertical rough adjustment screw, right? Note down that one. Behind we have another letter. It is not shown in here, right? It is not shown in here. Behind one is vertical rough adjustment screw. This one, vertical fine adjustment screw or vertical smooth adjustment screw. Smooth fine adjustment screw. Right. Okay, the next one, B. B is microscope adjustment screw. By turning this one, this whole one, right? This is already adjusted one. Right. Put it, this one is focused, already focused one. By turning this one, length of this one won't be changed. This length is a constant one, right? This length is a constant one. By turning this one, this is moving upward and downward, right? This whole thing moving upward and downward. Upward and downward without moving the vertical this component, right? Without turning this component here. Without turning this component, only this one is moving upward and downward. Done? Okay, clear. That is called microscope adjustment screw. Right. Then what about edge? By releasing edge, we can throw this one upward and downward. We can move this one, whole thing, right? With the microscope and this vernier scale and whole thing, we can shift them up and down, right? Okay. This one is adjustment screw. Adjustment vertical component adjustment screw. Vertical component adjustment screw, whole thing with the microscope and the vernier scale and the corresponding connecting setup is throwing one upward and downward, right? Okay, the A, vertical fine adjustment screw. B, microscope adjustment screw. C, sorry, H, vertical component adjustment screw. Okay, next one, C, level screws. C, level screws. Level screws. D, spirit level. D, spirit level. Spirit level. E, horizontal fine adjustment screw. This one, horizontal fine adjustment screw. Horizontal fine adjustment screw. But before operating this one, F is horizontal rough adjustment screw. But after releasing this one, we can shift this whole vertical pole here and there, right? After removing this one, after releasing F, horizontal fine adjustment screw, we can shift this one here and there, right? Okay, then first we have to well tight this horizontal rough adjustment screw should be well tied before operating fine adjustment screw into horizontal side. Clear with that? Right, okay. F is horizontal rough adjustment screw, E, horizontal fine adjustment screw, G is the passage, right? G is the passage. This is cladding one, cladding passage. And here we have main scale. This one is the main scale. It is not having the symbol, main scale. And this one is also vertical main scale. This one horizontal main scale. And here we have vernier scale. This one vernier scale, horizontal vernier scale. This one vertical vernier scale right here. Like that, okay? Right. Okay, right. Then see the question 212. A traveling microscope used in the laboratories given below. Using the parts shown, answer the following questions given below. Okay. Let's check the answers. Okay. What is the main advantage of traveling microscope when compared to the normal microscope? Right, 10 seconds to write the answer. Or just think. 10 seconds. Main advantage of traveling microscope when compared with normal microscope. Right, enough time. But a normal microscope doesn't have crosswire. Only we have telescope crosswire, right? Here we have a crosswire. There is a crosswire. Then as availability of the crosswire, we can adjust the crosswire to the image. Then exact measurement can be taken. This one is measurable one. Internal diameter of a tube, right? Or external diameter of a capillary tube, external diameter or internal diameter of a test tube. Such a small one, we can measure very easy, right? Thickness of a microscope slide, we can measure using this one, right? Okay, then in the traveling microscope, there is a crosswire. Then some readings can be obtained. Some readings can be obtained. See Roman 2. Keeping the entire traveling microscope horizontally leveled, okay, without getting inclined. The setup is not inclined. Is the prior adjustment that has to be done? Yes. State the letter of the labeled part used for this and mention the name referred by that letter. Okay. 10 seconds to copy the answer. Write down. What is the letter to maintain the leveling process and name of it? Okay, traveling microscope won't be inclined, no? So the letter is C. Yes, C. C. And name of it, leveling screws. Name them leveling screws. Right, Roman 3. C, Roman 3. Mention the letter and the name of the device indicated by the letter of the device used to check whether the entire traveling microscope is leveled. To check whether the entire microscope is leveled, which one is used? Right, 10 seconds. Enough time. It's D. That is called spirit level. D. Spirit level. Letter is D. Name of it, spirit level. Roman 4. Briefly explain how the traveling microscope is leveled. Turn the level screws. Okay, use 10 seconds to write for that. 20 seconds to write. We have 2 lines, no? By considering 2 lines, then you have to copy the answer. First, use 20 seconds to copy the answer. Right, enough time. How can we level the traveling microscope? Turning the leveling screws, turn the leveling screws or adjust the level screws. We have 2 level screws, no? By turning 2 level screws, obtain the horizontal leveling process of the spirit level. Right? Spirit level consists with air bubble, no? If it is perfectly horizontally leveled, the spirit, right? Air bubble in the spirit level should be at the midpoint. Then we have to say like this. Turn the screws, level screws, turn the level screws until, turn the level screws until obtain the, until obtain the, until obtain the middle position of the air bubble, middle position of the air bubble in the spirit level, in the spirit level. Right. See question number B, Roman 1. Right. See the question. State the letter of the part of traveling microscope used to prevent the microscope from moving horizontally and to do only smooth horizontal movement, and state its name. Letter. Okay. Take 10 seconds to complete that answer. B, Roman 1. Okay, read the question carefully again. State the letter of the part of traveling microscope used to prevent the microscope from moving horizontally. moving horizontally and to do only smooth horizontal movement and state its name. Then you are asked to write this one, right? Then we have to type this one before operating this one. Then answer should be F. That is called, say, the letter E, the name of it, horizontal rough adjustment screw. Horizontal rough adjustment screw. Roman 2. Mention why the letter of the part which is responsible to prevent the microscope from moving vertical and do only smooth vertical movements cannot be seen in the diagram. Yes, that is called, yes, vertical rough adjustment screw. It is laid behind the vertical component, no? Right. State the answer. It is at the behind position. It is at the behind position from the vertical component. Then it won't be seen, no? Yes. Roman 3. By keeping the lock tightened each time, an additional work is done. By keeping the lock tightened each time, an additional work is done. State the additional work done by this. Yes, Pudha? Use 10 seconds to complete your answer first. Yes, we have to do additional work. Example, if this is tightened, this one, when you rotate this one, this is very smoothly moving by a very little displacement. No? Then we have to do additional work to shift very small distance of this one, right? To travel small distance of the vertical or horizontal component, we have to do a large thing, large work done. ටිකක් වැඩිපුර කරකවන්න ඕනි මෙයාව චූට්ටක් එහාට මෙහාට ගෙනියන්න. As it is tightened one, right? State the answer. Yeah. After the component is tightened, it may be shifted. It may be shifted very small distance. Very small distance. Very small distance. When very small distance when turning the fine adjustment screw with the large number of turns. Right, Roman 4. Question B, Roman 4. What is the step needed to be taken in order to move the traveling microscope horizontally or vertically after tuning the screw used for that purpose? If this step isn't taken, even though the screws are turned, microscope doesn't move. Okay. What is the step needed to be taken in order to move the traveling microscope? Yes. Horizontally or vertically? Use 10 seconds. We discussed that one earlier. 10 seconds. Enough time. Then tight the rough horizontal adjustment screw and rough vertical adjustment screw. Tight rough adjustment screw and horizontal adjustment screw. Question C. Main scale of traveling microscope has half millimeter part. Half millimeter part coincided with 50 vernier divisions. Then least count becomes 0.01 millimeter. Clear? Yes. 0.01 millimeter. Next question D. The second prior adjustment which is needed to be done is to adjust the eyepiece. Briefly explain how it is done. The second prior adjustment which is needed to be done is the adjustment of eyepiece. Eyepiece lens is this one. We are going to keep the eye right here. This is objective. Objective lens, here eyepiece lens. What is the adjustment of eyepiece? We have to see this one and we have to move this one until image is clearly seen. Turn this one while looking through the eyepiece lens until clearly seen the image on the crosswire. Image should be clearly seen on the crosswire. Right. Write down. Turn B or turn microscope adjustment screw. Turn microscope adjustment screw until the clear image is seen on the crosswire. Until the clear image is seen on the crosswire. Until the clear image is seen on the crosswire. Clear with that? Right. D, Roman 2. After performing this adjustment, draw the image seen when we look through the eyepiece on the circle to the right. Then we can say, we can clearly see the crosswire and the corresponding image. If you are looking the external diameter of a capillary tube, we can see it like this, or right here, or here, or here, right? It is enough to draw the crosswire, right? But this one is already adjusted one, right? Not to be adjusted one. Then length, whole length from here to here, already adjusted. But we have to change the objective distance, right? Until the clear image is seen through the crosswire, right? Okay. Roman 3. State the letter in which device used to adjust in order to focus a certain location of the crosswire is marked with the name and devices. Then state the letter in which the device is used to be adjusted in order to focus a certain location. We have to turn this one by shifting here and there. Then letter is D. Letter is B, right? Letter B. And name of it, microscope adjustment screw. Microscope adjustment screw. Right. Let's take the other. Okay. Consider the instant where it is required to measure the internal diameter of a capillary tube using the traveling microscope wire. Traveling microscope. Answer the following part considering the two diameters of the internal cross-section perpendicular to each other as shown and observing from the front of the tube are AA1 and AA-, AA1 and BB1. Okay. How to measure AA1 diameter length? Next one. how to measure BB1 diameter length, and Roman 3, how is the cross-sectional diameter obtained by using the values of AA1 and BB1, right? We have to manage it, right? But that is not the exact location of the cross wire, exact location of the test tube or capillary tube, this one. This one is the capillary tube. This is not the exact position, right? Okay, let's see the process. Here we have the location of the cross wire. This one is the cross wire, home. Then needed to measure internal diameter like this. If you manage internal diameter right here, this scale reads this scale right here. Okay. Let this point A, A1, and here point is A. You can take the reading at here. Let this one R1, right? And corresponding this, let's see the process next. Here, this one and this one. The reading at here, you can say it's R2, right? R2. Now turn in the horizontal fine adjustment screw and vertical fine adjustment screw. You have to shift the capillary tube until here. Okay. We have to take like this, no? Then this line taken to this point, let it broken line. Of the second step, R2 shifted to this point, no? R2 is shifted to this point, and then this location newly read. Now this one is R2. This is R2. This one becomes R3. Here to here gap is called R3 minus R2 or R2 minus R1, right? This is called horizontal diameter. Horizontal diameter, DH, is this one. And the vertical one, let's see. R1 is now turned into here. This is R1 location, right? Make a shift. This is R1 position. Now this is called R1. And this position now becomes R4. Then here we have vertical diameter. R4 minus R1 or R1 minus R2, R4. That is called, yes, this one is vertical diameter, dV. It's better to say dH plus dV divided by 2 is the mean diameter. This is the way of taking the diameter. Okay, Buddha, right. Can you copy this one at a certain position? Right, here or anywhere. You can copy this diagram, right? This is the complete arrangement of the reading process, right? Can we manage it? Then how to measure BB1, including here. How to measure AA1, including here. Okay. we have to explain how to take AA1 and BB1. Before that, can we complete this one? Okay, write down the process. How to measure AA1 diameter length, right? Adjust both the screws. Adjust both the fine adjustment screws. Adjust both the fine adjustment screws until aligned with until aligned with until aligned with the internal hole of the capillary tube. Align with the internal hole of the capillary tube on both the wires. On both the wires. Then difference of the readings R1 and R4. Difference of the reading R1 and R4 gives BB1. Gives BB1. Here B1, this is B, right? A1. Difference of the reading R3 and R2. Difference of the readings R3 and R2 shows the diameter AA1. මෙතන යටින් ලියන්න Roman 3 by considering mean diameter of BB1 and AA1. By considering mean diameter of BB1 and AA1. Make a little pen, like, copy this one, like. Then mean cross-sectional diameter can be calculated. Mean cross-sectional diameter can be calculated. Okay. Question F. Enlarged readings are shown like this, no? So that this is vernier scale. Here, this one is vernier scale. This one is main scale. Here, vernier scale, main scale. So the vernier scale is already calibrated here, which means if 10 divisions are coincided with the main scale division, then reading is 0.1 from the main scale reading. It's centimeters. If 10 divisions, here 5 and here to here 10, then from here to here we have 10 divisions aligned. If 10th one is aligned, the reading is, the corresponding reading is 0.1 from centimeters, yes, 0.1 centimeters. Then here 0 division passes 80 millimeter, 81, 82, 82.5 completed, no? 82.5 millimeter completed, plus we have aligned one is here, ninth one. Ninth one is 0.09, right? Ninth one. 10th one is 0.1 millimeter, 1 centimeter, 0.1 centimeter, 0.1 centimeter. And ninth one is 0.09 centimeter. This should be centimeter, no? Yes. 0.09 centimeter. 9th division, right? It's here 82.5 millimeter. Excess we have 0.09 millimeter, not centimeter. It should be millimeter, 0.09 millimeter. It becomes 82.59 millimeter, right? And this reading is 82 point, sorry, it's 81 point, no, 80.5 millimeter plus here. 8 centimeter is 8 millimeter, 8 millimeter, and 0 passes 80.5 millimeter completed. Coincided one is 8.1, no? Here, upper 8.1, then plus 0.08 millimeter. This is indicated in millimeters, right? Okay. Millimeter point, 10 division aligned, millimeter dashama ekai. Here, 20th division aligned, millimeter dashama dekai, like that, right? Okay, then 80.58 millimeters. This one not in centimeter, it should be millimeter, right? 0.1 millimeter. Okay, then reading is 82.59 minus 80.58. It's here 1, 0, here 2. 2.01 millimeter should be the diameter. Okay, complete the answers. What is the reading of R1, RA, this one, RA dash, this one, and the mean diameter is this one, right? Now, copy the answer. Right, next part, let's start the other part is not topical one, to the topic should be mechanics, work, energy, and power, right? See the next part. Define the following quantities. Okay. First, identifying the basic part of mechanics, that region. That is the explanation of work, energy, and power, right? Can we write down? Work. Define work. First, use 20 seconds to define the work. You have 20 seconds to write about work, right? What is work? Write down. Work is the product of The product of force and distance. Work is force, product of force and distance. Okay, then work is Fs. Force is that will equal Fs. That given by joule, no? Yes, work is measured by joule. Energy, right? Define energy. What is energy? Energy. 10 seconds to complete. Yes, what is energy? Energy is ability to do the work. Ability of do the work. These two clear. Ability to do the work. Basically, work will be converted. Work will be converted to energy. In the syllabus, we are considering work done converted to mechanical energy, right? Mechanical energy, right? What is power? Next one. Power. Yes, rate of work done, no? Power is rate of work done. Energy divided by time. O power is force into velocity. Both these equations are correct, applicable. Power, rate of work done. Rate of work done. Okay, copy these two equations. Power equal energy over time and power equal force into velocity. Power equal force into velocity. Next one, 216. What is the relationship of work done on the object and mechanical energy of the object? Fundamental relationship, if there is no any other energy conversion, work done should be converted to mechanical energy. Write down here, work done converted to mechanical energy. Mechanical energy. Okay. Work done should be converted to mechanical energy if there is no any other energy loss. Okay. 2070. 207. Derive an expression for kinetic energy. Can we write to that? Yeah. Consider an object of mass m. Consider an object of mass m started from rest. Started from rest. Started from rest. Moves under an external applied force. Moves under an external applied force to obtain the velocity of v. To obtain the velocity of v, by covering the displacement of s. By covering the displacement of s. Done. The real statement is work done should be converted to kinetic energy. Work done should be converted to kinetic energy. Work done is Fs. Kinetic energy, let it Ek. F is replaced by using Ma into displacement covered is Ek. Then we can apply V squared equal u square plus 2as, final velocity v, initially rest 2 into acceleration a. Then as becomes v squared over 2, no? Replacement instead of that here. Then kinetic energy equate mass, no? M mass, as is v squared over 2. Then ek becomes half mv squared down. This could be the standard equation for kinetic energy, right? Can we copy this one? Right. Next one. Derive an expression related to potential energy. No? Right. Line එකක් කරලා ලියන්න. Consider a mass of m. Consider a mass of m is shifted vertically upward through the height of h. Through the height of h by applying minimum vertical force equal to weight. Vertical force equal to weight. Vertical force equal to weight. Right, then work done will be converted to potential energy. Work done will be converted to potential energy, mechanical energy conversion. Work done is Fs equal to potential energy EP. Then EP becomes minimum force needed to drag this mass towards upward is equal to 8. S is through the height of h. Then potential energy becomes mgh. Can we complete this one? This is also a standard equation. That Okay, next one. Derive an expression for elastic potential energy. Right. Can you introduce the basic process? Say it right. Consider a spring, a helix spring. Consider a helix spring whose vertically tightened through its one end and it is extended by the extension of x using the force of F. Using the force of F. Using the force of F. Right. Fundamental one. F is directly proportional to x. F becomes kx. This is first identification. And you have to say work done by the applied force. Work done by the applied force, right? Applied force should be converted to elastic potential energy. Work done is Fs, should be converted to elastic potential energy. But the particle at here is extended with maximum extension. Particle at the midpoint is not having the same extension. Particle at here remains same, right? Then particle by particle extension difference. This particle, let it A and here B and here C. A particle shows maximum extension, isn't it, Buddha? Here, it does have maximum extension. This one, relatively low extension. Here, extension is 0. Then the applied force is not delivered throughout the entire length of the spring with the same magnitude. Particle by particle, point by point, extension differ, no? Yes. Different values of the extension available here. So you can say this force is made with the mean force. Mean force, right? Okay, mean force is initial force 0, final force is F divided by 2, multiple by extension could be the elastic potential energy. EP becomes half Fx. Standard equation. Next one as well. F is replaced by using Kx. Then we have elastic potential energies half F is Kx into x. Then equation becomes half Kx squared, right? This is the next one. Clear? Okay, here we have elastic potential energy, basic equation, this and this. That one is the corresponding relationship of F and X. Okay. Complete this. Okay, next one. Write conservation of energy. This is called law of conservation of energy. Can we write? What is that? Total energy of an isolated system remain constant. Total energy of an isolated system remain constant. Write the topic, energy conservation. Write down, total energy of an isolated system remain constant. Total energy of an isolated system remain constant. Total energy of an isolated system remain constant. Okay. Question 221. What is conservation of mechanical energy? What is conservation of mechanical energy? That should be mechanical energy conservation valid only for elastic collision, right? Then we have to say total mechanical energy remain constant of an isolated system when elastic collision is available, right? In an elastic collision, total mechanical energy is conserved of an isolated system, right? Write down topic conservation. Question number 221, we don't have the topic. You are asked to identify what is conservation of mechanical energy. 221, write down. Total mechanical energy is conserved. Total mechanical energy is conserved total mechanical energies conserved of an isolated system in an elastic collision. In an elastic collision. Right, clear, Buddha? Done. Can we start question number 222? Now we have to do the questions, right? Okay, some starting now. Okay, 222. An object of mass 2 kilogram of the velocity 10 ms minus 1. An object of mass 2 kilogram, clear, of the velocity 10 ms minus 1 is experienced the force of 24 Newton. Then, after covering 100 meters, they need the velocity, no? Okay. They need the velocity, right? Consider energy conservation. How? Consider at here we have kinetic energy of mu squared available. Excess we have work done by the applied force. Initial kinetic energy available, work done by the applied force available, and then as the result of sum of these two, final kinetic energy will be prepared. There is no potential energy as it is horizontal leveled one. Okay, right, done. Can we simplify now? Quick as possible. Half m is 2, velocity 10 squared plus Fs. 24 into 100 equate half into mass 2, velocity needed to cancel 100 plus 2400 is v squared. V squared is 2500. Then V becomes 50 ms minus 1. Clear? Right. This is called use of energy conservation. Here, this is called application of mechanical energy conservation. Okay, right. If you finish that, start to 23. 223. Complete now. Right. Start next one. 223. Use 3 minutes to complete that. 223 within 3 minutes. Okay, 223. Let's see the process. An object is thrown by 20 ms minus 1, right? Thrown with 20 ms minus 1 on the rough plane of mu equal 0.4 after traveling 40 meters here to here. 40 meters. The object reaches to the rough inclined plane of angle 30 degrees shown in the figure. Find the maximum height traveled by the object on the inclined plane if coefficient of friction of the inclined plane is a different one. No? Here, horizontal plane is 0.4, inclined plane is 1/2 root of 3. Then what is energy conservation here? First thing you should identify, at the beginning we have half mu squared, right? That is the initial mechanical energy. But a part of that mechanical energy completely destroyed due to the frictional force minus F1 S1 on the horizontal plane. F1 S1, right? F1 S1, clear. F1 is frictional force. S1 is the displacement covered by the object under that frictional force of 40 meters, clear? Right. And another part of which means from the mechanical energy, right? Initial mechanical energy is this one. Part of that one destroyed. Destroyed means for the converted to heat or any kind of other stuff, right? That is not including in the mechanical energy. Mechanical energy, this one is the initial one. That should be the conserved one. And part of that one lost, and another part from here, S2, S2, F2, S2 minus F2, S2, right? Let this 1000 joule of mechanical energy, part of that one converted, part of that one is used to overcome that friction. Initial 1000, this one 200 lost, this one 500 lost. The loss of value of 500. This right? The rest of 300 should be potential energy, mgh, like this. Can you understand this one, brother? Most doubtful one, right? Several students don't identify this one. It's easy here. Kinetic energy at the beginning, half mu squared. Part of that one lost and another part lost, then rest of value converted to potential energy. No need to consider kinetic energy during the motion, right? Initial kinetic energy identified and part of that one liberated due to the friction and finally obtained potential energy as this height. Can I have the simplification? Half, mass is not mentioned, no? Half m velocity 20 squared minus F1 friction mu r s 40 meters plus F2 mu r is mg cos theta cos 30. Displacement is here to here 2h, no? This is h tan sin 30, no? Sin 30 equal S O H over S, no? S2. S2 is sin 30 is half, it's 2h, right? It's 2h equal mgh. Done. Simplification. Half into mass m 400 minus mu 0.4 r is mg into 40 plus mu 1/2 root of 3 mg cos 30 root 3/2 into 2h equal mg10 h, no? Yes. mg cancel, mg cancel, mg cancel, mg cancel. Here mg 0 cancel, right? Simplify this one. 40 by 220 minus 0.4 into 40, no? 0.4 into 40, we have 16, right? Here minus root 2 cancel. And here 2 cancel. here h by 2, equate here h. Then here 4 equal h plus h by 2, no? 4 equal 1.5 h, 3 over, then h becomes 8 by 3, 2.66 meters is the vertical height that is going by the object. Clear, Buddha? Right. Complete the simplification. Okay, let's finish 224. Okay. An object is released from top of an inclined plane of 45 degree as shown in the figure. All the surfaces are rough and the object comes to rest after traveling 100 meters. Rough. Mu values are mentioned, no, in the diagram, right? Find the height of the inclined plane. They need this height, no? Okay. Again, use the energy conservation. Initially, we have potential energy, mgh. Part of that one liberated as frictional force, F1, H1. Or F1, S1, right? Another part is converted. Again, another friction we have, F2, S2. And finally, velocity becomes 0. Then total energy will be converted like this. Here, potential energy at the beginning, mechanical energy, right? Part of that one liberated due to the frictional force on the inclined plane. It is a different value compared with the horizontal plane. This one belongs to the inclined plane. This one belongs to the horizontal plane. Final one is 0. No matter, right? Done. Then mgh minus f1 s1 minus f2 s2 is 0. Done. Substitution. M g10 h to be found minus f mu r s1 minus mu r2, here r1 s2. Final answer should be 0. 0, there is no kinetic energy as well, no potential energy. Let this level 0 potential energy level. Then sine 45 equal h over height over displacement s1, right? Then s1 becomes root 2h. Simplify this one. mgh minus mu. Mention 1 over 2 root of 2. R1 is mg cos 45 vertical component perpendicular to the plane. S1 is root 2h minus mu 0.2 x mg. Distance travel 100 meters. No? Final 0. Simplify this one. All the points are having mg now. Mg cancel, mg cancel, mg cancel. Rest of cos 45, 1 over root of 2. This one and that one cancel, no? Yes. 1 over root of 2 cancel. So here h minus, we have here h over 2 root of 2 equate this one taken into the other side, right? 20. Now, on the unknown factor is h, no? Then we can find h. This is the way of taking the final answer. Complete this one, brother. H divided by 2 root of 2 h minus nearly 0.35 h. Then h becomes h is 30 point, new value 75 meters, right? Now,